Welcome back. The next law in gas law is Charles' law, and Charles' law states that the volume of a fixed mass of a gas is directly proportional to its absolute temperature, pressure kept constant. So when we keep the pressure constant, the volume is directly proportional to temperature. Now, if I remove this proportionality sign and include an equal sign, I will have a constant multiplied by the temperature. And if I divide everything by temperature, the constant will be V all over T. And in such a case, that one brings us to the expression for Charles' law, which is just V1 all over T1 is equals to V2 all over T2. Or rather, if I cross multiply it, I will have V1 T2 is equals to V2 T1. The absolute temperature is the lowest temperature at which a gas can exist, and that one is normally equal to -273 degrees Celsius or 0 Kelvin. So at -273 degrees Celsius, that is the absolute temperature, or rather 0 Kelvin. And we can have graphical representations of both. So when I use degrees Celsius, this will be the shape of the graph. So when I plot volume against time, but in degrees Celsius, I'll have -273 degrees Celsius. I'll extrapolate it from there and I'll have a straight line. And what if I have Kelvin? Remember, on Kelvin, I said it is 0 Kelvin. Therefore, this will be the shape of the graph. Y, X, temperature, but in Kelvin. And I have volume. I'll have a straight line from the origin. It begins from 0 Kelvin. Now, let's discuss a very simple question. A mechanic was filling a deflated tire with air in his closed garage using a hand pump. The capacity of the tire, have this in mind, the capacity of the tire is 40,000 cubic centimeter at room temperature. And room temperature is normally given at 25 degrees Celsius. Then he rolled the tire into the car outside. The temperature outside was 30 degrees Celsius. Explain what happens. Now, when given such a question, you must always calculate first before you do anything else. Now, as we have it in mind that in Boyle's law, this is the expression, Charles' law, V1 all over T1 is equals to V2 all over T2. This is the same expression we are going to use in this question. So which variables am I given? I'm given the volume. So volume 1 is equals to 40,000 cubic centimeter at room temperature. And what is the room temperature? It's normally given in terms of 25 degrees Celsius. So T1 is equals to 25 degrees Celsius. Now, I must convert it into Kelvin. Therefore, I will add 273. That one will give me the temperature 1. Now, we are also told that the temperature outside was 300 degrees Celsius. So I must get V2, and the temperature 2 is equals to 30 degrees Celsius. I must add 273 so that it can be in Kelvin units. So I calculate the value for V2. And how do I get V2 from this expression? I know that V1 all over T1 is equals to V2 all over T2. What do I want? I want V2. So I cross multiply. When I cross multiply, I will have V1 T2 is equals to T1 V1. And if I divide everything by T1, I will have V2 to be equivalent to V1 T2 all over T1. So how do I get it? What is my V1? 40,000 times 40,000 cubic centimeters times what is T2? T2 is 30 plus 273 will give me 303 Kelvin. I divide everything by this plus this will give me 298 Kelvin. 298 Kelvin. So the Kelvin will go with the Kelvin. So when I punch that one in my calculator, what will I have? 4671.1409 cubic centimeters. So this will be the volume at what temperature? This temperature. Now, what were we told? Explain what happens. But again, we were told something. The capacity of the tire is 40,000 cubic centimeter. That is the volume of the gas that the tire can contain. But what will be the volume at this temperature? It is 4671.409 cubic centimeter. It means that this one is above the capacity. So what will happen? The tire bursts. So that is how we can answer such a question. Now, I'd like to give us a very simple way of remembering the two laws, Boyle's law and Charles' law. So this is the simplest summary on the two laws, on Boyle's law and on Charles' law. So on Boyle's law, temperature is constant, and on Charles' law, pressure is constant. And in Boyle's law, it is the inversely proportional, and in Charles' law, it is directly proportional. So that is the simplest way in which we can summarize the two laws in gas law. Thank you very much. Don't forget to subscribe on the channel. Bye.